watch magic. All right. Okay. So today, what we're doing, we are reshaping data and we are joining data. Okay. So our goal today um, is to take data files and what we're going to do is we're going to take individual level data and we're going to compress it into aggregated counts. Then we're going to take that data and join it onto another data file, right? So this is part of what kind of generally gets referred to as data cleaning and data wrangling, right? And these are key tools for the budding uh, data analyst and social scientist. So we have our files, hopefully, in our working directory, right? You can see I go to my terminal and just type ls to see what my current files are, right? Ls is a list current directory, and you can see that I have my popnat.csv and my fatalencounters.csv files, right? So that's where we're going to start from. I'm going to start a new script. First, I'm going to library in tidyverse because the one thing that the tidyverse is good at many things. The key things that it is just a killer app for are like data wrangling and data visualization. So I'm going to save this in my labs folder. We'll call this lab reshaping. Tidyverse is also getting updated all the time. So there's two new functions today that I'll show you, pivot longer and pivot wider, that are pretty cool. They replace gather and spread. So the other cool thing about Tidyverse is it's under active development and being improved all the time. But let's get started. So I'm going to call, so just follow along and we will, you know, just interrupt me with questions as they come up. I have the chat window open so you can either put questions there or you can unmute yourself and ask questions as we go. Either way is fine with me. So let's read in that first file. I always forget file names because my short-term memory is more or less shot because of children and sleep deprivation. So I'm going to read in fatalencounters.csv. And let's see there. So I'm just going to highlight it all. I hit Command A and Command Enter to just read those. Command Return on a Mac, on a PC, it's Control A, Control Return, or some really quick hotkeys to just run the whole thing. Now I got some messages here, right? There's some parsing problems with this. In particular, there's date issues, right? We can see here there's 11 parsing failures. So it said, you know, I thought row 9298 was going to be a date variable. I expected to see a double, and instead I got this #ref exclamation, and that's just an internal spreadsheet error in the original data. Original data is always messy, right? And so part of our job is to fix it. But we see out of actually this whole, you know, like I think 20,000 row file, we've got 27,000 row file. We only had 11 parsing failures, so that's pretty darn good. For those of you who don't know what this data is, this is a unofficial archive of every person that's been killed by police between 2000 and more or less today. So this is 27,000 documented police-involved killings. Each row is an individual in the data, and I've used this data quite a bit. So it's one that I have a lot of experience with. It's also one that's really messy. So it's a good exercise for us to work with. Messy in terms of how it's formatted. It's not really formatted for social scientists. It's compiled by journalists. So we have a lot of work to do to clean it up. But let's take a look at head. Okay. So when we get new data in, head. Okay. So we've got a lot going on here. So we see that we've got a unique identifier, the subject's name, the subject's age, the subject's gender, race, and then about 30 other variables, right? And I can do names to look at the names of those variables. So we've got a lot of good stuff in here. We've got latitude and longitude. We've got the agency responsible for the death. We've got the cause of death. Some of these are better variables than others. But what we're going to focus on today is just a few. We're going to focus on subject's age, subject's gender, and subject's race. Okay. So what I want us to do is start by renaming those variables. Okay. So does anyone remember what the command in tidyverse is to rename a variable? This one is easy. Nope. Mutate creates a new one. Mutate's fine. Mutate would work, but we would leave the old variable intact if we mutated something to a new name. What if I want to take one variable and just replace it with a new name? Just rename it. It is rename. This one was, yeah, a cheat. Okay. So, yeah, rename. And I want my new name to be, let's say for subject's age. What would be a good variable name for subject's age? I'm just going to use age, right? Age equals, and I'm going to use this. You can use either double quotes or the tick. We'll just use double quotes because everyone's familiar with that. Okay, so when I do that, let's now look at names FE and see what happens. Now, instead of subject's age in position 3, I just have age. And that's far easier to work with than typing out quote subject's age every time. The idea is when we have spaces in variable names and we have special characters like hyphens, we have to wrap it all in quotes rather than using it just typing it out without quotes as we can do in tidyverse. So it's much nicer to just put it in a convenient format. The other one we want is gender. Gender equals subject's gender. And there's no reason I couldn't just copy and paste from the names down here. So I'll just do that for the last one. Subject's race. And we'll do race equals subject's race. Okay, now those are the only 3 variables I want. So I'm going to select age, gender, and race to get a compact data frame. And I'm going to rerun the whole thing, because why not? Now, I've got a really compact data frame. Actually, I'm sorry, I wanted one more thing. I wanted year. I forgot about year. Because we need to adjust this for annual populations. Okay, so I want that date year, this last variable. So let's rename that as well. Year equals date year. So let's start with year, age, gender, race. Try that. Okay, that's great. So we have now all the records in the data, but we've just removed everything that's not the variables we're looking at. In the full paper, I used a couple other variables as well, but this is what we're going to work with today, just to keep things on the simple side. Okay, so let's take a look at these. Someone type in the box, let's say I want to see all the values along with frequencies that occur for race. How would I do that? Someone throw that in the chat. There's a tidyverse approach, and then there's a base approach.
What's the question again?
My question is, I want crosstabs by race. How do I get a table that shows me how many values are observed for each category of race? And there's a tidyverse way to do it, and then there's a base way to do it.
Filter?
Table FE dollars, yeah, so table is good. Table FE race will do it, right? The other thing I could do is I could do FE group by race, summarize, n equals n. I could use the n function, parentheses, to count. And that'll give me the same thing. Same values anyway. But table is fine. So let's look at the tidy output just because it's a little easier to look at. So here's our first check for cleaning. Anyone notice any problems here? What are some problems we see?
Some really small n's, so you can probably just collapse categories.
Some small n's. What are those small n's? Tell me about this.
So
Hispanic Latino is counted.
Hispanic, Latino, Latina. Latino's twice. The spelling is just different with like a capital I.
Yeah, row 7 is a typo.
White.
And there's no reason we can't collapse row 5 and row 6 because we also have gender included. So Latina doesn't give us any additional information.
Yeah, the same thing with European. Sorry, my music was on. I forgot.
Oh, you're good.
My European um American white hyphened and not hyphened.
That's right.
Just
That's right.
overlap.
Yep.
And then, well, I mean, race unspecified is a huge has a huge number, which means we could potentially drop that, but
Yeah,
we just need
we're not gonna
unknown.
drop it, but in the paper I do missing data processes to handle it, right? And we'll talk about that into the semester. We're not gonna do it today, but yeah, but the typos are definitely something we can deal with, right? So let's fix those typos. Fix the typos. Anyone want to guess how we're going to do that? We're going to do
Mutate.
Name.
a mutate. That's right. We're going to do a mutate, and we're going to do it with case when, right? So case when is a function that lets us provide. So we're going to say, I'm sorry, let me start this over. So we're going to mutate, and we're going to transform our race variable. And we want to basically give it all the categories that we want to use in the final version of it. Okay, so let's say case when we have African American black, right? I'm going to reduce that just to, we're going to say just to black, because that's a little easier to work with. I'm going to take these long names and kind of compress them. So we'll do, the categories I'll use are black, API for Asian Pacific Islander, white, we can use Latinx for Hispanic, Latino or Latina. Uh, Middle Eastern, it's only got 46, and I think that count is bad. And I know in the census it gets collapsed into white for ridiculous reasons. We can leave it alone or we can collapse it. I don't actually have population data for that category from census because it's until recently been treated as a subset of white, which is politically something. But we aren't talking about the politics of demography today, unless we want to. Um, and then Native American Alaskan will collapse to AIAN, American Indian or Alaska Native. We'll just treat race unspecified. We'll relabel that as an NA. So is everyone kind of following me that we want to take these complex categories and give them simple labels to make them easier to work with? So I'll say case when race equals equals, because remember we use two equals signs for comparisons. We'll say race equals equals. And I'm just going to copy and paste these labels because it'll be really easy for me to make typos on these, right? Especially when there are typos. I'm going to say when race is equal to that, African American, African hyphen American slash black. Then I'm going to do a tilde to say when it's equal to this, do this. And when it's equal to that, make it equal to black. Next, race. So I'm going to do this for every single value that's in this table, right? To recode it to where I want it to be. So this is a pretty traditional recode of a variable from one thing to another. Case when is a really great function for that. If you have a variable that only takes on two values, if it's binary, then if else will do the job for you a little simpler. But case when is great if you have a lot of categories to deal with. So for Asian Pacific Islander, we're going to turn that into API. For this one, we got, oops, didn't copy it correctly. So this part is easy to screw up with typos. So make sure to check your work after this, right? By just running table again after we do our recode and make sure the values line up. And we'll confirm it after we're done. Okay, so there was the hyphenated European American white. We'll say, nope, you're just white. Okay. Here. Oops. And if we, wanted to save time, I could just copy and paste the whole line, right? And then just sub in the values as we go. Often what I'll do is I'll count out. So that's 1, 2, 3, 4, 5, 6 more. Okay, so that's 1, 2, 3, 4, 5, 6, right? And then we'll just kind of go from there. So here, this one, and this will be Latinx. Okay, here's this one. All right. So what we're doing is we're compressing these categories, right? what we're doing is we're taking a larger number of categories in and recoding them so that they'll compress down when we summarize by group. Oh, that's wrong. Okay, so now, yeah, those. This is tedious. Data cleaning is tedious, right? No way around that. But it's part of the game. And just about every data system. Yes, you could definitely do it. So Christiana asks if we had a continuous variable, could we do it the same way, but using numbers instead, e.g. 18 to 24 is young people. And I'm going to show you that in a second because we're going to need to map on the age categories onto age ranges. So we're going to do that. Yeah, we could do this for anything. Case win is super flexible, right? And I'm just going to, race unspecified is going to be NA, right? I'm going to make it an explicit missing value. It's not in quotes, so R knows that that's missing, right? Okay, so now that's our mutate. That's a long mutate, right? But we need it. Okay, so I think I've closed everything. Why are you not showing me that? Okay, cool. So must be a character vector. Okay, you want it to be in quotes. That's saying a logical vector. NA is logical. So it wanted it in quotes for some reason. I don't quite understand why, but we'll go along with it. So now look at our table for FE $ race, right? Now we still see that 8,814 missing, as we saw up here. We have 278 American Indian Alaska Natives. Yes. Asian Pacific Islanders, 410. Good. Black should be 5841. Latinx should be bigger than 3547, right? It's plus this one, so it should be 9. 3549 or 3. Huh. That's fine. We lost one. I'm not going to worry too much about it, but ordinarily I would go back and hunt down that case and figure out where I lost one. Anyway, we compressed it. Before we had 10 categories, now we've got 6, right? That's good. Okay, everyone following so far? Yeah? Cool?
Could you use like grapple to find all of the categories that have like HISP in it and
Yeah.
then
Yeah, you're thinking like a programmer. That's great. Yeah, so you could simplify this by using, Sophia suggested using grepl, which is a function that uses regular expressions to hunt for patterns in the data, right? Pattern matching and replacement. So what you could do is you could search, because we know that the string HISP appears only in these 3 categories. So instead, we could do something like grepl, and grepl returns true false when it meets a category. And the pattern is H. We need to, I forget how to do wildcards for lowercase. We could do like star SPANIC because we have a capital I in one of them. So if SP, I mean, even just if star panic appears anywhere, or even just panic, we don't need the star. In race, then that should work. I'm not going to run it just because I'm not actually convinced it's going to work, but something like that would work, right? Where we could think about the patterns in these initial codes to reduce the amount. So if we basically could say search for white. If white's in there, call them white. Search for Hispanic or some subset of the word Hispanic, or even just we could use Latin, right? That's in all 3 of these. That would be fine. And then we could use that to make the assignment rather than typing out every single category. So yeah, when you get kind of further ahead, you can start thinking a little more in terms of how you can use code to simplify your work a bit. grepl would be, and regex is another kind of abbreviated form for regular expressions, is a great tool for manipulating characters and strings that if you're going to work with this kind of data a lot, is a skill to develop. I always spend a lot of time on Stack Overflow trying to figure out what I'm doing whenever I use regular expressions. I have not mastered it, but I do use it occasionally. It's really powerful. Okay, so head FE. Okay, now let's do the same for gender. So let's check out gender just to make sure that we look okay there. So let's do table fe $gender. Okay, so we've got some problems here. We have white as a gender and femaler as a gender, and then I guess transsexual is a. Some of this was not input by the same people, so you get people using different labels. Again, messy data, right? Okay, so let's collapse. I guess transsexual will go into transgender, white will go missing, femal R will go into female. Is that good? Okay, so we're going to do mutate gender equals case when gender equals. And here, you know what? Because I'm going to show you the if-else approach, just because we only have a few things, and rather than explicitly coding everything, we'll just catch our mistakes. So I'm going to do nested if-elses. If-else gender equals femal R. So what if-else does is it says, go check if that condition is true. If that condition is true, do this. If that condition is false, do something else. So in this case, what I can do is I can say, if it's not equal to femalar, then leave it alone. Make it equal to gender, right? That would be if I only had one condition, I could leave it there. I'm going to show you, that's kind of how we've seen if-else used in the past. But I'm going to nest it. And what that means is I'm going to say, if it's not equal to that, then go check if it's equal to something else. Gender equals transsexual. So if gender is not equal to femalar, if it is equal to femalar, turn it into female, and then we're done. If it's not equal to that, check to see if it's equal to transsexual, and then turn that into transgender. And if it's not equal to transgender, we have one more to fix, and that's white. If it's equal to white, then we want to make it missing. And the way it works is it's going to go sequentially. First, it's going to check this first condition. If it's not equal to this first condition, it's going to check if it's equal to this second condition. If it's not equal to this second condition, it's going to check if it's equal to this third condition. If it's not equal to this third condition, I'm done now. So I want to tell it to return what was already there, because everything else is already good, right? Or at least I assume it is. I'm going to tell it to return the original variable. So this is kind of the base way to do case when, is to just nest a lot of if-elses together. I typically now will use the case when approach. It's a little more explicit. It's a little easier. Why can't we use, because you could, if you wanted to use transsexual as the category. I don't think that's how many trans people identify themselves. So I'm using transgender instead. Yeah. Yep. The idea is, and if we wanted to, so if you need a reminder on if else, right? Question always pulls up the help file. So if else takes a test and then has a yes and a no. So the test is a logical, that is like, is this it's going to go through the entire vector, and it's going to compare each element of the vector to your test condition. And it's going to say, if it is yes to the test condition, then make the assignment that's in the second argument. If it's a no to the test condition, then do the thing, make the assignment that's in the no condition. But in this case, we're putting another if else in there. So it's not going to make an assignment there, it's going to go to the next condition. So we have three nested conditions at this point. This is, I think, a little more difficult to understand than case when. There is a case when version of this we could do that I won't show you, but we could effectively make an exit condition for case when, where we could say, if it's any of our problematic categories, here's how you make the reassignment. And then we could make our last condition just true, and then to leave it alone for the last condition.
Can you show us how to check it to make sure that we did the coding properly with this if else nested thing?
Yeah. So the way to check it, right, is to look at your original data. Okay, there's the original data. And let's not, instead of overwriting it, let's make this just, we'll call this temp until we're good with it. Okay, run our code. And so we have table fe $gender. We have table temp $gender. I want to compare these two, right? And so based on these two, I can see that this one, this female R, got reassigned to female appropriately, right? Because it was 2626 in the original data, now it's 2627. I can see that transsexual got reassigned to transgender appropriately, and I can see that white got reassigned to missing appropriately. That's how I would check it, is just to go back and look at a table of the assignment I made and compare it to the original and just make sure all the categories add up appropriately. You're going to make mistakes with this. This is a difficult skill to master, and it does kind of just take practice to get your brain kind of thinking in these ways. But you'll get it. Yeah, again, data cleaning is just something that you're going to do a lot of, and it's important to just kind of get your chops going on it. For what it's worth, this is something I had to teach myself as a graduate student, and it wasn't fun. So I'm hoping to get out in front and maybe make life a little easier on you all. But yeah, so there's that. Cool. Any questions on the recoding? That's how we recode categorical variables. We can use case when or if else. I typically prefer case when. Okay, no questions. So let's see where we are now. I'm going to make this into the reassignment. I'm just going to rerun all my code just to make sure. I'll often do that. I'll just re-execute my whole script if there's nothing too computationally intensive in it, just to make sure that everything, sometimes, we can overwrite things, and I want to make sure that the sequence of my script works appropriately and gives me the expected output. And there, that looks pretty good. Let's look at age. I know age has problems. We may just kind of skip it. Yeah. So there's babies in here, and that's horrible. This is one I solved with a grep, and I wrote some fancy code to deal with this. If you want to see how I dealt with this, if you go to the GitHub repository I'll post a link to it 1 second. I'm not going to go through the coding because it's a little messy, as you can see. I'll post a link to the script if you want to see how I handled this. I'll do it later. I'll post it in Slack later. Anyway, for now, we're going to remove non-numerics from age, just to make life a little easier on ourselves. Ordinarily, what I would do is I would go and find, in this case, Sophia, I did use regex. I used a grepl to find anything that had the word months in it that was less than 12 and assign that to be 0 years old. Anything that had months in it and was more than 12 but less than 24 to be 1 year old, right? And I think those are the only cases. And then these 20s to 30s, or these ranges, I basically took the two endpoints of the ranges and put it in the middle. So someone who was labeled as 20s to 30s, I just assigned to be 25. Or actually, I think I treated it as an NA and imputed it, but there's a lot of different approaches you could do for that.
You probably had to do that visually, like manually, right?
Yep, just go through it and find all those. Yeah. I could imagine a way to automate it, but because there were relatively few categories, about an hour of work to just do it manually. If this was a problem I was going to encounter in a lot of different data sets, I would think about an automated way to handle it. But I'm not going to go through it with you all just because it'll take too long. But what we'll do for now is we're going to mutate age equals as.numeric age. And what that's going to do is it's going to coerce anything that has characters in it to be missing, right? Because it can't turn S or months or days into a number. So anything that has non-numeric characters in it is going to just become an NA. And we'll see that. So table FE $age now, they're all gone, right? So that is dropping the data, and that's almost always a bad idea. because we're losing information, right? Because there is information in those, it's just going to take work for us to recover it. And ordinarily that's worth doing. Because this is just an exercise, we're not going to do it for today. The other thing is I'm going to top code age. So everyone who's older than 85 is going to get coded as 85. Actually, we'll do that when I get to the pop file, because you'll see why I need to do that in a second.
So do we not want to do the as numeric age, is what you're saying?
I'm saying that's how you can turn everything that has characters into missing, but I did just lose information.
Got it. So you want us to avoid doing that.
Yeah, what I actually did for the paper is I did a very long case when
Got it. Okay.
to correct
That makes
all those where I had information. You never want to throw information away.
Got it.
Yeah. Okay. So, but there we are. Okay. So I am now, and that warning NA is introduced by coercion is R telling me, hey, you just threw away information, because I can't actually turn months into a number, right? In this case, that's what I wanted to do. Let's just confirm that year looks okay. I believe it does. Yeah, year looks fine. Okay. And that's 485 already recorded police killings in 2020, which is pretty devastating because we just hit into March. All right. Okay, so now we're going to read in the population data. So now we're going to look at joining. No, yeah, I want to read in the population data so we can see what shape we want the other data to be in. Read in the pop data. Okay, so I can tell you where the original data is if you're interested in that. This is data from the CDC's CDC Wonder creates like a very nice age-specific population data file that I use a lot. So we're going to read it in and call it pop, is read CSV pop_nat.csv. Okay, and that should read in without a problem. And there is what it looks like. Okay, so we have the year of the population. This is a national population count by race, by sex, by age, and then a total population count for that bucket. Now, we're going to have some issues here that we need to deal with because table pop age, right? These are the categories we've got, right? As Christiana suggested a second ago, we're going to need to think about turning our continuous, or rather our integer age measure, into a categorical, right? The other thing we could think about doing, and what I end up doing in the paper, is just kind of, instead of doing 55 to 59, just having 5-year buckets for ages. So I'll have 0, 1, 5, 10, 15, instead of having it as a character, right? So what we could do is we could just pull that first number out. But we'll go ahead and code it like this for now. Okay, so we need to, what our goal then is to basically, what we want to do is we want to estimate rates of death by race, sex, and age. That was the goal in the paper. And so in order to do that, I need to take my death counts and join them onto the population data so that I can get per capita rates of death, right? Now, once I have those, then I run those through a model. We're not going to do that today, but we're gonna go from here. So first, we need to make the FE data the same shape as the pop data, so we can join it. And it's not the same shape right now, right? What's the difference between these two data files? What shape is the fatal encounters data in right now? What unit of analysis is it at?
The first one is it looks like
The FE table. What's the unit of analysis for FE?
Oh, with the individual.
It's the individual. And the unit of analysis for pop?
Like
population.
Yep, it's the race, sex, age group, right? So the fatal encounters data is individual level, right? The pop data is national level by age, sex, and race. So we have very different analysis right now. So we have some reshaping to do. So let's reshape reshape the FE data to be national level by age, sex, and race, right? Good? Now, before we do that, we're going to want to make our age category match up, which is kind of a pain in the butt. And I kind of forgot about doing that when I thought about this exercise, but you know what? You all are game, right? Let's do it. It's going to be fun. Okay, case when age is less than 1, tilde. So we're going to say, I'm sorry, I always forget this step. Age is equal to case when age is less than 1, 0. So let's just say I want to see these categories in pop to make sure I get them right. So I'm going to use unique to retrieve all of the categories that appear in age. Now, what I did in the paper is I used regular expressions to basically go through this file and take everything that's not a minus or a plus and take the numbers in front of those and return that as the value for age, right? So I took either the first one or the first 2 characters from each of these age categories and made that the value, and then did the case when to make it match. But we'll do it this way. Age less than 1, 0. Age, so if age is less than 1, it's 0. If age is less than 5, then it's 1 to 4. Now, the other thing is this is sequential. Case when allows only one condition to match, right? And so what it's going to do is if age is less than 1, it's going to get coded 0, and it's not going to look at any of the other conditions for that row of the data. So whichever one it hits first is going to return. So in this case, my range is 1 to 4, but I don't need to say age greater than 0 because that's implied, because that was a prior condition. So all the prior conditions are implied in my comparisons, and I don't need to have a 2-directional, less than this, greater than this kind of comparison. I can just keep going. So I can go age less than 10. You can't see 5 to 9 on my uniques. That's because it's not in numeric order, right? Because it doesn't understand this as a number. It's treating it as a character. So that's bunched with the 50s now. So now we'll do age less than 15, 10 to 14, age less than 20, right? And you can see how this is going to get tedious, but it's not going to take us too long. And I'll post this code when I'm done if you really don't want to type along with me. I can respect that. And again, this is a case where there is almost certainly an easier way to automate this, but because I'm only doing it once here, I'm not going to bother. The automation will take longer in the initial steps to set it up, but would save you time in the long run if this is a task you're going to repeat over many different files. The thing I would actually do in my research practice is just go copy and paste this code off of the code I've written before to do exactly this thing, right? Which I'm not doing here just because then you won't see how it works. But here we go. Any questions about this while I keep typing away? No? Okay. No, it makes sense. I'm glad. The other thing you can do is if this is something you're going to have to do often to reclassify ages into buckets, is you could write this as a function and then call it to repeat over multiple different files. Again, because we're only doing it once, I'm not going to bother with that right now because it takes a little more programming. But it can be worth it if you're repeating operations many times. And so now we did age less than 80, 80 to 84. So we know we're going to do age greater than or equal to 85 is going to be 85 plus, and then we're done. Okay, so that was a lot of code, but let's see what we get. There we go. Check that out. Now, if I really wanted to, I could go through and confirm that those are correct based on the underlying age distribution, but I'm going to just let it be for now. Okay, so that one way I can confirm that my age categories map onto the population age categories is to use set notation, right? So I'm going to ask here the intersection of FE $age, the unique values in FE $age, with the unique values in pop $age. So set notation, right? We're going to ask basically, remember your Venn diagrams? We're going to ask, is the set of all the values in fatal encounters age now the same? Does it completely overlap the number, the categories of values in population age? Where do those two sets intersect? And they intersect all the way across. Oh, wait, false. Which one's false? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So category 10 doesn't match. 1, 2, 3, 4, 5 to 9 doesn't match. Okay, so this is how you check problems, right? Um, Oh, NA is the one that's not matching. Okay, that's fine. NA cannot match. The rest match, so I'm good. Everyone clear on how I caught that and then what I checked out? Okay. So again, when we're doing these recodes, it's really, really important to check your work. If you don't, if you just push on without checking to make sure the categories overlap, without checking to make sure there's no typos, all the joins and reshapes we're going to do are not going to work. And you're not, so it's really important to, after each step, confirm that it did what you wanted it to do before you push on. Because it can be really hard to debug this stuff if you keep going and you don't remember at which stage of your complex recode you made the problem. You'll have to go back through the entire code to find it. So you can save yourself a lot of headaches by checking your work. Okay, so now our fatal encounters data should be recoded in a way that'll join onto our pop data. So let's make it now, we're at the individual level. Now we want to aggregate it, right? So we're going to aggregate it to the national level by age, sex, and race. Oh, and by year, right?
Can you just copy the FE numeric data into the chat so we can?
You mean the one
also,
I just? Yeah. This?
Yeah, that right there.
Yep.
Yeah.
Cool. It's in the chat. There you go.
Thanks.
No problem. Yeah, and maybe I'll experiment with using Slack because it pastes code a little easier. Maybe I'll just start like a lab channel. We can post code in there next time. Okay, so now let's aggregate. This is going to be less code. We're done with the tedious part. So who remembers what function we can use to aggregate data? There's a pair of functions we can use. Okay, so first we're going to group by all the levels we want to group by. And in this case, we want to group by year, we want to group by age, we want to group by, we called it gender, and we want to group by age. Okay? Then we want to summarize. What summarize does is it applies some operation over the grouping variables, right? And it needs to be a summary operation like sum or mean or n will count, right? But it needs to be an operation that takes a vector and returns a single value for summarize to work. Otherwise, we're still doing a mutate, right? If it takes a vector and returns a vector, then that's a mutate. If it takes a vector and returns a single value, that's a summarize. Now summarize, if I don't group, will just return one value for the whole data frame. But if I group by, it'll return as many values as I have in each category, right? So in this case, we want to do deaths equals n. I want to count the number of deaths in each category. And what I get is this. This is called long data. This is data where we have each, and this is the kind of typical format that tidyverse likes to work in, right? Where we have each column is a variable name and each row is a variable. So we don't have variable names in the columns. Now, hypothetically, you could imagine, so this is the format we want to work in, but I'll show you why. Here's how we go to wide. And this is going to be a bit of a struggle for me, so bear with me.
Hey Frank, sorry to interrupt.
Not at all.
Before you go further, can you do the same thing with race when we recoded race? Can you copy that code into the chat as well?
Of course,
Thank you.
no problem. There it is. Okay, so this is long data. So I'm just going to pull it up in view so you can see it. What we have is for each year, for each age group, for each gender, and for each race, we have a count of deaths. Now, we actually are not quite 100% there because the zeros, I don't believe, are going to appear. So we're going to need to fill those zeros in manually. We'll do that in a bit. We'll do that when we get to the join. But you can see that for 2,000, 1 to 4-year-old female American Indians, Alaska Natives, 1 death was recorded, right? And then it's going to go through each category for each group. So maybe I'll sort it by race so we can see this work, and by gender, and by age. Right, so here's 2,000, and it's going to go for each year. We're going to get an entry for that, and then it's going to scroll up. Okay, we're in male now. But anyway, you get the idea. It's long data. So this is perfect for the kinds of visualization tools we use like ggplot. Right? This is the perfect format for ggplot because now we can take race and make it an aesthetic variable. We can take gender and make it an aesthetic variable. We can take age and make it an aesthetic variable. We can take year and make it an aesthetic variable. And then deaths is going to be what we're interested in. Right? Deaths will be the X or the Y we're after plotting. So this is really nice. Often what you'll see and for Stata users, this will probably be what you're used to, is seeing data in a wide format. So tidyr and the tidyverse functions have 2 functions, pivot wider and pivot longer. Now these are new functions, so I'm still kind of figuring out how they work. But pivot wider widens the data, right? So it increases the number of columns and decreases the number of rows. Right now in FE, we should have a number of rows that's equal to the number of years times the number of age categories times the number of gender categories times the number of race categories. We're going to have a few less than that because of the zeros, which we're going to have to backfill, but that's 2,500 rows, right? So now I want to pivot wider. I'm going to take names from race and I think then values from equals deaths. And we want ID columns as well because we have variables that identify the data, right? Like we're going to spread race. Basically what we're going to do is we're going to get 1 column for each race. And then we're going to have gender, age, and year stay as columns. We do year, age, gender. This should work. Yeah. So first I want to see that we've reduced the number of rows. We were at 2,500. Now we're at 762, right? So we've spread out race over the columns. And here's what that looks like. Here's what the wide data looks like. Is now, instead of having 1 column where race, 1 column for deaths, now we have 1, 2, 3, 4, 5, 6 columns for deaths. All those NAs are zeros, right? But it didn't know to fill zeros. I think I can tell it values fill equals 0. Let's do that. I think that's what that will do. Sorry, I changed my mouse behavior. Yeah, values fill is the argument. So that'll make those implicit missings. No, never mind. I won't mess with that. But you get the idea, because we're not actually going to work with this data. I could clean it up further. But everyone clear how this is wider than the last one? When we say wide, we mean more columns, but fewer rows. When I say long, I mean more rows, but fewer columns. But now we have a variable. Our variable race is spread out over column names. That's typically not what I want. Typically what I want is race in a column itself. So the tidy approach to data is to have all columns as variable. All variables are in a column, and column names are just labels, right? in this case, though, we could spread it out, and we could imagine spreading it out further, right? And I imagine many of you have seen data in this format before. A lot of like the criminal justice data comes in this format, and it's not great, but it is what it is. Okay. If we have wide, here's how we go back. So pivot longer is the inverse of pivot wider. I think I specify my ID calls again. Names. Again, these are new functions, so I'm still kind of getting my head around them. They replace, so if you have used gather and spread before, these are the new versions of gather and spread. Okay, so names 2 equals race. And I specify the columns I want to, all right, I don't even need to do this. I can just specify the columns I want to collapse. So I'm going to tell it in this case that I want to go AIAN. I want to take the range of column names from AIAN to API. And I want to put those names in the race variable. That ought to do it.
Isn't FE already long though? So don't you want to do it to FE wide?
Oh, you're right. Thank you. You are absolutely right. Okay. Oh, I gotta put that in quotes. Got it. Okay, so now FE long should get back to where we were. Now it's filled in those missings. I didn't have here. I didn't have zeros before. So I'm gonna actually have, I think I've actually inadvertently done what I meant to do, what I wanted in the first place, which was my zeros. Yeah, so you can see I've got a lot more rows now in FE long than I had in FE wide, because what implicitly happened is it took all those values where I didn't have zeros in the data, and it filled those in with missings, and that's a good thing. Okay, that's all confusing, but we're going to work from FE long now, and I'm going to mutate those NAs into zeros with an if else. Okay, so I'm going to say mutate value equals if else value equals rather is dot NA value 0 value, right? So I'm going to say if value is long, then turn it into a 0. Or if value is NA, then turn it into a 0. And you can see all those NAs now are zeros. And that's exactly what they should be. A summarize, basically, if there's no count in it, it doesn't report back the 0. I don't think it's a good behavior of summarize, but it's something it does. And you need to be aware of it because zeros are data when we're counting things. Okay, that was a lot, but I just wanted to show you how the wide and long differ from each other and how to move between wide and long. So that wasn't a great comprehensive introduction to it, but those help files are really useful. So if you go to the help files for pivot longer, you'll see when we go down to the bottom, these exercises. I don't know how many of you know this, but I can just execute these help files directly by just highlighting the line of code and hitting Command Enter. So this shows me this relig income table just by highlighting it and running it. And then here's a pivot longer example right beneath it, right? So I can take that and turn it into that. So the help files are really great for just reminding yourself how this works.
So,
yep.
But does gather and spread still exist in the tidyverse package? Can we just use that if we're familiar?
Yep.
Okay.
Yep. If you really like gather and spread, they're there. They are no longer being updated. So they're what's called deprecated. They'll work, but they're not going to get updated anymore. I think they may do like small bug fixes here and there, but the development energy is now moved to pivot wider and pivot longer. And having used both, I do think that pivot wider and longer are much better, easier to use functions than gather and spread. But your code with gather and spread will still work. So no worries about that. But I do think, it's worth learning the new functions. Okay. So that was a lot just to get our messy data into the shape we want it, but now it is, right? So let's think about the join. So let's remind ourselves what popNat looks like, or pop rather, not heat, head pop. Okay, so there we go. Now notice that we have this race problem as well, so we're going to need to fix that. Right, the race categories don't match what we have. But instead of going back and writing new code, I'm just going to go back to our function up here that recoded things and make these categories match what's already in the population data, rather than writing out a new function to change these. So I'll paste this new code in so yours will work just fine. Latinx and white are already good. Does everyone follow what I'm doing right now? I'm just making the categories and fatal encounters match the categories that already exist in the population data. There's the new code for that. Okay, so I'm going to run the whole script again. Oh, right. Now my code for the pivot doesn't work because the column names are different. That's okay. Just got to replace that. And that's. Sorry. Of course. Things don't work when I mess with my code. That's okay. Just debugging things really quickly. Okay, so now I tried to make this, we'll just leave it value, that's fine, and I'll do a rename. I'm working fast here just so I can get us through this. Okay. Okay, so FE long is now what we want it to be. Pop is what we want it to be. The race and because the pop data uses sex and not race, we'll rename sex equals gender, which all you gender scholars in the room must be internally going nuts. We're going to do that. But there we go. Again, the politics of demography are beyond the scope of what we're doing today. Okay, so the join now. So we have, let's do FE, call it FE pop. So we have a bunch of different joins. I know Christiana talked about this a little bit in lab already, but so we have a lot of different categories of joins. One way I want to make sure that our data is complete, right? So I remember I mentioned before in my initial group, I summarized that, I can just show you what that looks like. Table FE $age, right? We don't have even numbers of category of values in each age category when we should. Right? We should have like 280 in each category or something like that. But because there's a lot of years where no one dies in that age range for each sex and each racial or ethnic category, we end up with different values in that. But if we look at the FE long, it's going to have them all. No, it's not. Okay, so we're going to need to do complete to do it, or we're going to need to join onto the pop. Because when we look at pop, 280 across the board, right? Each category has, so we have complete population data for each year, for each race, for each sex, for each age. Now we have more years in here, so we should have more total categories. But there's two options here. We could, to fill in the missings, we could use the complete function is one way to do it. That's the way I typically go, but instead we're going to join onto pop, right? So population is complete, right? The only thing it's missing is, well, it's not missing anything. It doesn't have an NA category for population because it doesn't have, like, how do you count the population of missing race data in fatal encounters. You can't do that. So those data are going to get lost when we do this. We're going to join onto pop, and we're going to use a left join to do it. Now, there are lots of different kinds of joins. There's left, there's right, there's full, there's inner, there's outer. I always use left. I exclusively use left just because my brain can't handle all the complexity of all the different kinds of joins. So I basically choose the data set that I want to be that has the structure that I want to preserve, and I join things onto that. And in this case, pop has the structure I want to preserve. So we'll call it FE pop. I'm going to use a join. And what complete does, and if you read the documentation for complete, is it actually does a bunch of joins to create the complete data file. But we're going to start with pop, right? Pop is going to be our dominant object in this. It's the structure we're going to join onto. So I'm going to use pop, and I'm going to do a left join onto pop of FE. Now I could just do left join, and the left is that pop is on the left and FE is on the right. That works the same, but remember, if I pipe, this implicitly becomes the first argument. I like the piping layout. Okay, so it's going to join by year, race, and age, right? Which is exact, oh, because we didn't get sex renamed appropriately, apparently. Yep, it's still labeled as gender here. Oh, it's because I joined onto FE, not FE long. Okay, little errors all over the place. Okay, so it's telling us the columns. Basically, what join is going to try and do is it's going to try and join by the column names that are identical in both data sets. You can be explicit if you want to, if you have column names that don't match up, but I find it easier to just make the column names match. So it's going to take every value of year, race, sex, and age, and those are going to be unique values in each table, and join those onto each other. Let's see what that looks like. Okay, so we know that we don't have any data in fatal encounters between, so the 90s are out of the data, right? So first, let's filter year greater than or equal to 2000, because we know 2000 is the lowest year we've got in our fatal encounters data. We're going to drop pop data prior to that, but now we should have what we want, right? And let's confirm FE pop $age. And we do have an even number of rows for each age group, which is what we want. But we know that those NAs are zeros, right? There were just basically no deaths in the data for, infant girls killed by police who were American Indian Alaska Native in the year 2000. Thank goodness. So we're going to mutate those away again. We're going to say deaths equals if else is.na deaths, 0 deaths, right? So if it's NA, turn it into a 0, otherwise leave it alone. And those zeros are now all those NAs are now all zeros. Okay, this is what we were after, right? This is the table we were after. So from here, now I can do things like, let's just do it as a new operation. I could continue to pipe onto this forever if I wanted to, because I am unhealthy with the length of pipes I like to include on things, but let's do a new one. Let's say death rate, and we're going to make this into deaths per 100,000. Okay, so let's say that we want the death rate to be deaths over pop times 1E5. That's deaths per 100,000. Okay, and so now we have deaths per 100,000 in that year as a category, as a new variable. And from here, we could do all kinds of fun stuff, like ggplots, FE pop, AES, X equals year, Y equals death rate, color equals race, and then we can, this is going to get kind of tricky because of age, but we could aggregate this up. So maybe we want to make like a line plot of death rates per capita across age groups over time. That sound good? So we could aggregate the FE pop data further. We could say FE pop, let's call it total. So now we're going to compute total mortality rates per capita by year. Okay, so we're going to collapse age is what we're going to do. We're going to group by year, race, sex. We're going to summarize deaths equals sum deaths, and pop equals sum pop. Then we're going to mutate death rate equals deaths over pop. But wait, you say, couldn't you just do that all in the same command? Of course I could. Death rate equals sum deaths over sum pop, right? Okay. So now I get annual death rates. Oh, right, that's just percentage of people killed. We want to make it into per 100,000 because otherwise the numbers are very, very small. Okay, so there's our death rates per capita. Now, do you want to plot it? I do. This will look a whole lot like a figure from the paper. So let's do AES, X equals year, because we're going to do a time series plot. Okay, so this is a really basic time series plot. Y equals death rate, color equals race, and then I'm going to facet it by sex, because I want to have one plot for men and one plot for women. And I know that there's about an order of magnitude difference between male and female death rates. So I'm going to let the scales be free on the y-axis. I want basically us to be able to actually see the variation. Oh, well, I'll show you why we do that. So let's first plot this. Okay. Ooh, I didn't do a geom line. I should have you all debug my code. I am making a lot of mistakes today. Okay. So here's what the death rates look like over time. Note that I don't actually think the death rates have increased this much. I think a lot of this is censorship, and I explain a lot of that in the paper. But why don't I show you the data? I do believe. So we'll filter year greater than 2008. So we remove those early years in the data that I don't think have good information. So I do think the death rates have gone up, but not by that much. Can you see the popped out plot? Yeah? Okay. Okay. So here we have death rates over time, right? We can clean up these axes. We can force the axis to be an integer because 2017.5 isn't especially meaningful. But we see a pretty big increase over time in mortality rates, peaking around 2012 and kind of declining a little bit after that. Black men have the highest death rates. American Indian men also have pretty high death rates. Latinx men also have pretty high death rates. Asia Pacific Islanders have lower death rates, right? We can see that the death rate for women is lower, but if we want to make the death rate for women and we want to kind of put it on a scale that isn't relative to men's rates, but it's relative only to their own, that's where I did the scales equals free y to tell it, let it be free on the y, don't constrain it. And then now notice we get two different y-axes. We get one y-axis for men and one y-axis for women, right? If you really want to look at within group differences, that's a good way to do it. You just need to keep in mind that note the scale for men goes from 0 to 2 and the scale for women goes from 0 to 0.2. Right? That's that order of magnitude difference I was talking about. So that's reshaping and joining and cleaning. That's a lot. But what I just walked you through was like 50% of the data cleaning work I had to do on that paper, right? Now, there's obviously other things to deal with, missing data, all this other stuff. But if you, these are skills that, when you start working on your own stuff, you're going to need to practice a lot of. But yeah, that's more or less the lesson for the day. I think you can't underestimate, though, how important it is to get really good at data wrangling, data cleaning, and reshaping your data. And once you get, especially into the kinds of worlds we live in where we use a lot of administrative data, it's going to be dirty, and it's going to need to be joined onto other data sources to pull in all the information you need, like population data, like perhaps I often work where I take data on incidence rates of something like a police killing or a child welfare system contact, pull in population data. I may pull in budget data from the agencies, all kinds of things, right? So we can pull in 10 different data sources. And as long as we can have consistent labels for time, for place, for the category of person we're looking at, there's no reason we can't join 10 files together, right, to expand the amount of information we're able to work with. So this is a really critical skill for everyone to start to develop. So questions? No? Okay. Well, you don't have to do any of this on your homework this week, but you could conceivably, and maybe I'll change this into the homework challenge. This is actually not a bad idea, to take the Poisson, the logistic regression that we assigned you for homework this week for Titanic deaths, and to turn it into a count model and to run it through a Poisson regression, right? And we could use the reshaping, the group by summarize, to turn things into counts, to reshape it. We could use that to basically get similar inferences from a different kind of model, right? We, sometimes lose information when we aggregate, but certainly something we could think about doing. You don't have to reshape anything for homework this week, though. This is more of a general things you ought to know lesson. So, okay, with that, I guess I will see you all on Friday. If you want to make office hours appointments for tomorrow, the details are on Slack. Without anything further, see you all next time.